Every day, millions of us use products that have been designed and made using matrices.
But how many of you know what they actually are?
How much do you know about matrices?
I don't know anything about them.
Like, can I just get a cheese and tomato 12-inch, please?
Yeah. Anything else?
Do you know anything about matrices?
Like a matrices?
No idea.
Do you know anything about matrices?
About what?
Matrices. Have fun!
Know about matrices? Know about matrices?
Not much.
What do you know about matrices?
Absolutely nothing.
What do you know about matrices? Matrices.
Matrices. I know a little.
A little.
Yes.
Looks like you could use a bit more information on matrices. What they are,
What they're used for and how to use them.
luckily for you, that's exactly what we're going to do.
Before we get too much into matrices, we need to find out what they are.
Basically, a matrix is a rectangular table or an array of numbers.
An array can have as many columns or rows as needed. You can have 2 by 2, 3 by 3, and so on. That's generally surrounded by 2 large brackets.
If you know anything about vectors, these may look pretty similar. That's because they're basically the same thing. A matrix with only one column or row is called a vector.
The numbers in a matrix are called entries. They're generally referred to by their position, much like coordinates, say A11, 12, etc.
It is also possible to get 3D over dimensional arrays, as well as consolidating any square matrix into a number called determinant. However, this is way outside the scope of the video, so we won't be including it.
Okay, now let's look at some simple calculations using some simple matrices.
We are going to work with these two example matrices, A, which has 1, 2, 3, 4, and B, which has 5, 6, 7, 8.
Addition of matrices is really easy. You just add up the corresponding values in each matrix to give you your answer. So using algebra, just add up A11 with B11 and so on for each entry. Using our test matrices at the top, we just add up the values. So 1 plus 5 is 6, 2 plus 6 is 8, and so on, giving us our answer.
Subtraction of matrices is very similar to addition, where you just subtract the corresponding values. However, it is important to remember that A minus B is not the same as B minus A, as you can see here.
Multiplication is a different story, which can be quite tricky. However, there's a simple technique that you can learn which makes multiplication with matrices ever so simple. Using our example matrices, we take the columns of B and lay them over the top of our A matrix as rows. Once the leftmost column of B is laid over the top of A as a row, we let it filter through the matrix, multiplying as we go. We multiply each corresponding value from row A with our row from B to fill the first column of our resultant matrix. So here we get the first entry of the first row in A, which is 1, and multiply it with the first value from the row we adapted from B, which is 5. We then do the same for the second values and add them together to give us our answer for entry 1, 1, which is 19. We then do the same for the second row of A, still using our row from B to give us 2, 1. So 5 times 3 plus 7 times 4, which equals 43. Once the leftmost column of A is finished, we take the next column of B and repeat this process to get our entries for column 2. So 6 times 1 plus 8 times 2, which is 22, and 6 times 3 plus 8 times 4, which is 50, completing our answer. Once you learn this technique, it's so easy to multiply any size square matrix. We will quickly run through a 3x3 one to show you. To demonstrate, we are now using two new example matrices, both with entries 1 to 9. So our first column of answers is calculated by bringing the first column from B over, just like before, then placing it on A, then calculating it just like last time. So we have 1 times 1 plus 4 times 2 plus 7 times 3, which equals 30 for the first entry, and so on for each one. We then, just as before, take the second column from B and repeat the process, giving us our second column of answers. And finally, do exactly the same for the third column. One last quick point. If you ever have large numbers in a matrix, like we do here, you can always use a coefficient to make them a bit more manageable. This is easily done, as you just find the highest common factor, in this case 3, and divide each number by it. If you ever need to multiply out again, simply multiply each number by the coefficient to get back to your original answer.
So now we know how to use them, let's see what they're used for.
One of the most used functions is to draw 3D objects on a two-dimensional screen. For example, like this. This is called perspective projection, in making the objects look like they have 3 dimensions whilst drawing them on a two-dimensional plane.
This moves on nicely to representing linear space, which is also done using matrices. This can be done using 2D or 3D objects, using matrices to calculate their position, such as a vector on a graph.
They can also be used to manipulate 2D images, for example rotation, scaling,
Reflection and translation. And that's it from the M team.
What do you want to do now then?
I don't know. Pub? Yeah?
Yeah!